Well, hello and welcome to the third in my series on cosine and sine rules. This is a revision. This is a revision exercise based on an iGCSE maths question here. And it says we're given a triangle, and then it says if you go five, ABD is a triangle in which AB is equal to C, and so on and so forth. And it says calculate to 3SF. Okay, so that's very important really when it comes to the calculation. We require 3SF for all the answers we're going to have. So there are five parts to this. There are five parts to this question here. And the first one says we want to find the length of CE, and the next one we want to find, and CE, by the way, CE is there. Okay, and the next one says the size and degrees of angle BCE, and BCE is there. Next, we want to find the length of ED. Now, ED is there. And next, we want to find the size in degrees of angle ABE. Angle ABE is there. And finally, part 5 says the area in centimeter squared of triangle ABD. Now, triangle ABD is all of these. All that's triangle ABD. So you need to find the area of that one there. Okay? Right, moving on. For the first one, what I've done is to isolate this triangle there. And that's what we got there. Okay. Now we want to find CE there. Now opposite CE we got 20 degrees. And 20 degrees is an included angle for sides BE and BC. So the cosine rule will apply, which gets CE squared is going to be BE squared plus BC squared minus 2BE BC cos B, where B in this case is 20 degrees. So now CE squared is now 36 plus 64, because 36 squared is 36 and 8 squared is 64. Add those together and subtract the product of 2 times 6 times 8 cos 20 degrees. CE squared will be 100 minus 96 times 0.09398. Now, we now find this product here, 96 times 0.09398. So we end up with 100 minus 90.2105. And if you take the square root of both sides, CE then becomes square root of 9.7896. And CE will then give us 3.12887. Now, because we want to answer to 3SF, and the fourth significant figure is more than 5, so that will go up to 3. So CE then becomes 3.13 centimeters to 3SF. Now for part B, we're still with this triangle there for part B. So for B, we want to find the angle BCE. So we want to find this angle here. Okay, we want to find this angle BCE there. Now this time round, because we're looking for this angle C there, we know the length of this side BE, and we just found the length of CE, and we know the angle opposite CE, and that's 20 degrees. So sine rule does apply in this case here. So we end up with sine C over 6 is equal to sine 20 over 3.1287. You don't want to work to beyond for SF, but it doesn't really matter in this case. It doesn't matter. So sine C then becomes 6 times sine 20 over 3.12887. Okay, sine C will then give us 0.6558 4.86. Now, the inverse of that, hopefully, should give us the value of C. Now, I've got the figure here of 41.0 degrees. Now, it makes sense to add the zero there because working to 3SF. So C is actually 41.0 degrees. Okay, this added it. Makes sense to add 0 there. Okay, now for the next section, we want to find the angle ABE. Now to do that, I've now isolated this triangle here. Now we know from part B that this angle here is 41 degrees. And if that's 41 degrees, this angle here has got to be 180 minus 41, which is 139 point whatever, 0.015, I think it is. So that angle is 139. Okay, I want to find ED, which is this one here. Now, we know the angle opposite ED, and that's 139. And we know that 25 degrees is opposite CE, and we just found that CE is 3.13 or 3.12887. So the sine rule will apply in this case. So we then do ED over sine 139.01, you don't have to put 0.015, that's being pedantic there, is equal to 3.1287 divided by sine 25 degrees. So we then end up with ED is equal to sine 139 times 3.128 divided by sine 25, and that gives us ED, a value of, that gives us ED as equal to 4.857, and to 3SF becomes 4.86 centimeters. Okay, for parts D and E now. Part D says we want to find the angle ABE, and that's angle ABE there. We want to find this angle there. And before we do that, we want to find this angle here. Okay, now this angle here is an exterior angle, or one of the exterior angles for triangle BED, this triangle here. So if that's an exterior angle, it means that this angle here will be equal to the two interior angles. In this case will be 20 and 25. So this angle here is 45 degrees there. Okay. Now we want to find angle ABE there. To do that, we need to find this angle first, and then subtract from 180 because we know this angle, and find this angle, and then subtract from 180. That we need sine rule to find this angle here because we know this is 45 degrees, and we know the value of the side opposite 45 degrees. Now we know this side of 6 centimeters there, and the angle opposite we do not know. We do not know this angle here. So to find this angle, we need to use the sine rule, and that's what we got here. So sine BAE, this one here, divided by 6, which is the opposite, the angle A, is equal to sine 45 divided by 7. So sine BAE then becomes 6 times sine 45 divided by 7. We get sine BAE at 0.60609. If we find the inverse of that, that will then give us angle BAE of 37.307 degrees. Now, because we're looking for angle ABE, we'll have to subtract 45 and 37.307 from 180 degrees, which means that angle ABE will then give us a value of 97.7 degrees to 3SF. So angle B or ABE is 97.7 degrees. 3SF. Now, for the final part, E, the fifth section. Okay, here we go. It says the area in centimeter squared of triangle ABD. Now, if you look at triangle ABD, there are three sections there. That's this one here. There's this one here. And finally, this one here. So we take it in turns. This one first. Now, we know this side 8 centimeters. So we know this side 6 centimeters. If we use the formula half BC sine C, because that's an included angle there. So the area of this triangle is going to be a half times 6 times 8 sine 20 degrees. And that's what we got there. So triangle AB, the area of triangle BEC is half times 6 times 8 times sine 20 degrees. And that will give us a value of 8.208 centimeters squared. Now note that I've not done any approximations yet. So this is the 4 SF there. Now next, this big triangle there. We know 7. We know this the value of side BA. We also know the value of side BE. And we just found the value of sine B there. So half BC sine A will apply here. So now the area of triangle ABE will be half times 7 times 6 times sine 97.69 degrees. Okay, note that I'm using 4 SF here again. And that will give us a value of 20.81 centimeters squared. Now, notice again, this is 4 SF there. And now for the last triangle, the smallest of the three, okay, and this triangle CE. Right. Now, that's 41 degrees exterior angle. That's 25 degrees there. And because 41 is an exterior angle, this angle here would then be 41 minus 60 minus 25, which gives us a value of 16 degrees. So this angle is 16 degrees. So we know the side CE, we know the side ED. There is an included angle of 16 degrees there. So half AB sine C applies. So the area then becomes half times 3.1287 times 4.8567 times sine 60 degrees. And that gives us a value of 2.094 centimeters squared. Now to find the area of ABD, we then add all three values there. Okay, we add the areas of the three triangles there. So area of triangle ABD would now be area of EBD plus area of ABE plus area of CED, and that gives us an area of ABD of 31.114. And working to 3SF, we have the value of ABD being 31.1 centimeters squared. Now, I hope all that made some sense. And please subscribe. Thank you for watching. Bye-bye now.